I don't know why it says this. Obviously, this is 7.1. And hopefully 7.2 we'll get to today. Now, I've mentioned this many times. What are the two types of statistics? Descriptive, and we've done what? Statistics, right? We've never made any inference, right? Today is the first day where we'll do inferential statistics, okay? So this is kind of a big deal, right? Because this is the actual idea, right? And it's harder to do because, right, if you know the whole population, you can make really good, accurate probability statements, right? But here we're going to look at inferential statistics, right? So notice before, right, we told you if you know the actual population mean, right? The actual population standard deviation, right? I was able to tell you, right? Use that formula, right? I was able to tell you if you take a sample from that population, right? We were able to figure out what the probability was that the mean of that sample would fall in between particular values, right? And we use that, right? We did that by knowing that if you have a sample that is big enough, right, the sample will be the sampling distribution, even if the initial population is not, will be what type of distribution if the sample is big enough. It will go, yes, it tends to a normal distribution, and we know that the mean of the sampling distribution, right, where it predict should be the mean of the population, right? And the standard deviation, the standard deviation of the population distribution, is that also equal to the standard deviation of the population? No, how do I correct this formula, everybody? What? I mean, yes, that would be definitionally true, right? But that's right. That's just the that's just the identity property of equality, right? But what's the formula? How do you do this? N, where N is the sample size, right? We've mentioned this enough times, guys, that these should be seared into your memory, right? If you're having to look through your notes for this, I'm a little worried. But we're going to use that formula enough times that hopefully it will be seared, right? So it's not correct. I hope that this is portion. Let me make sure I have the right slides here. Okay, perfect. I don't know why I had the wrong titles there. I apologize about it. So remember, a population proportion is what proportion of people will vote for a Democratic congressional candidate, right? What proportion of people, whatever, right? It's usually some sort of yes or no question, right? And we figure out the population. We want to estimate the population proportion, right? You can have a sample proportion, but like this is not something that really belongs to an individual, right? An individual either likes ice cream or doesn't, right? When you have a sample, you can talk about like what proportion of it likes ice cream, right? And we're going to estimate the portion of a population, right? Let's just think about how we would do that. And then we just need the statistics, right? So how would we estimate, say, the proportion of the population that prefers vanilla ice cream to chocolate ice cream? It's a large number of people in America, right? Let's say we're talking about all Americans, right? So I don't have access to all of them. What can I do? Say that a little louder. Right. So you look at a sample, right? And maybe you find out 30% is of them prefer vanilla to chocolate, which means we would guess that maybe 30% of the country, right? We wouldn't be surprised if it was 31% or 32%, but we would be surprised if it was 80% or 50%, right? So we're going to figure out like, right? But if I said 40%, you're like, I don't know right? So we're going to figure out where that band that's expected kind of is, right? And we're going to do that. Notice that's going backwards, right? We're inferring something from a sample to the population, right? And you won't do it with certainty, so we're going to be talking about, like, give me a bandwidth that I'm like 95% sure that I'm in there, right? And that would be wider than a band rate, a band, right, where I could say I'm 70% sure that the actual population proportion is in this band, right? So that's what we're going to kind of go through, right? So that's all this section is population proportion. You might think mean sounds more interesting. That's maybe more likely. The mathematics for the population proportion are just a little bit easier. Right? So we need to be able, at the end of this lesson, you should be able to calculate a confidence interval for a proportion, right? I'll explain what that is, but that's roughly, I'm some level of confident that my proportion falls between 15% and 30%, right? Whatever it might be. You're going to have to explain that in more detail. Also, right, we need to figure out, like, hey, right, if you, I mean, there's an election going now. You've seen polls, right? It gives you a plus or minus a certain percentage, right? You will, well, one, it doesn't tell you the confidence level typically, but you can find that in there, right? Given the confidence level and your plus or minus range, right, how big does your sample have to be, right? The bigger your sample is, the more certain, or, well, that's confident, right? Certainty is not something that really happens. The more confident you are that you're there, but how big does it need to be to give you a specific amount of confidence? I want to be 95% sure that I'm within the actual value by 1%, right? You're going to be able to figure out how big your sample needs to be to do that, right? Really, if you can get an A on this chapter, if for one thing, you would be able to be a professional pollster. But there's one reason why you wouldn't be able to. Anyone can think about that? What that might be? What is the best type of sample that's hard to get? A random sample, right? Everything that we're going to do assumes that the sample is random, which we know it's not. Even if you randomly select people, they can choose to be in the sample or not, because it's a free country. Okay, point estimate is just a number, right? So if I'm on a point estimate, right, that's, right? So Regina, how tall do you think I am? That is your point estimate, right? So that is your best guess, right? So your point estimate is your best guess, right? But you, in your mind, have some range, right, that you might say. So, right? So let me just give this to you, right? So first let's talk about the terminology, and then I'll tell you what it is there. So for this, right, Regina says 6 feet. Now we're going to talk about what this means exactly, right? This isn't there. So Regina, now tell me, give me two heights that you're 95% sure that I'm between. Okay, so that's when you're saying you're 95% sure, right? If I said 100% sure, you might have to say 0 to 100 feet, right? But 95% sure she's saying right? And it turns out I normally quote myself as 6 feet. Usually what I measured, I'm just a tad under it, right? And now I spend a little bit, I've shrunk just enough that now I'm closer to 5'11" and a half than I am to 6, right? You shrink more when you're older, but I've shrunk just enough, right? So this is our confidence interval. So it's a range of values, right? And then your point estimate is your best guess, right? No, and then your sample size is how big does your sample need to be to get a particular confidence interval, right? The sample proportion, right? So you're saying, so your point estimate so we use p hat to estimate is our point estimate of p, right? So let's say I have a sample, right? And 30% of them prefer vanilla to chocolate, right? And I tell you, right? And if your life dependent, like if I say, tell me what you estimate to be the actual portion of the population that prefers vanilla to chocolate, you're going to guess, if your life depended on it and you had to choose one value, you're going to guess 30%, right? Because the only thing you have is the sample portion, right? That's what this is saying. So a point estimator is a number that is your best guess, right? It's a little more formal than a guess. It's your best guess for a population parameter. And the best thing you have is the sample value, right? So and it is, and we find out that p hat is an unbiased estimator. What does it mean that it's unbiased? Does anyone remember? That's kind of, but there's a more formal, yeah. Okay, but it's not competitive, so that's might not, let's be more specific, right? So what range though? There's a very specific definition for on bias estimator, and we went over this, right? It's been a while. Like we said that range and some other things were bias estimators, but mean, right, variance were. So, and hopefully if you did the homework, do you remember that I had you do homework where you looked at a sample, right? And you would do the means of different parts of them and compare it to the sample mean, right? Right. So for example, you might have 3 pieces of data. I think we did one where we had 3 children, right? Ages 4, 5, and 8, right? When we looked at the different samples of 2 children, does this sound familiar, right? And we found out that the mean of all the means, the mean of the sample means was the mean, right? So that's what it means to be an unbiased estimator. So that means, right, suppose the percent of a population, right, that has some characteristic is 30%. Right? I take a sample of 10 people. That, if I take a sample of 10 people, am I guaranteed that exactly 30% of them, let's say 30% prefer vanilla to chocolate? If I take a sample of 10 people, will necessarily 30% of them prefer vanilla to chocolate? No, right? So maybe my p hat's a little bit bigger, right? Then I get a different sample of 10 people, might be overlapping, might be a completely different group of 10 people, right? That's another p hat. I get all these different p hats, right? Some are bigger than the actual p, some are smaller. But if I did every group of 10 people, the mean of all those groups would be 30%. That's what an unbiased estimator is. Right? A bias estimator is where this is not true. For example, the range of a set of data, right, is a bias estimator. If my data set is 1, 2, 3, 4, 5, 6, 7, 10, my range is 9, right? Any sample of 2, I could take a sample of 2, 1 and 4. That has a range of 3, right? Is everyone following what I'm doing? If I take all my samples of 2, right, I'll have different ranges. The only way I would have a range of 9 is choosing 1 and 10. That would have a range of 9, right? So all my ranges will be at most 9. Most of them will be smaller than 9, right? So the average of those, the mean of those ranges would be less than 9, right? The ranges are not centered around the estimates for a range, right, from each sample are not centered around the actual range of the population. So that means it is a bias estimator. Does this sound familiar? You guys did it. There was the homework assignment for 6.3. If you did it, you were doing this for different pieces of data. Do you guys remember doing that? So this is probably pretty old, and this might be, let's say this is America. It's probably a long time ago, right? Now it's much more universal, although I don't know, some of you young folks aren't using Facebook because, I don't know, it's for boomers or something. I don't know. I'm old enough to have used Facebook when it was cool. And when it was exclusive, you used to have to go to college to be on Facebook. Yeah, that was around when I was in college. Yeah, I'm a lot older than y'all. Okay, so they took a sample of these 1,487 people, right? And of that sample, 43% of them said that they had a Facebook page, right? So notice this 43%, this is a proportion, right? Is it a sample proportion or is it a population proportion? Right? So we indicate that with P or P hat. P hat is correct. Bobby said that quietly because he wasn't sure, but that's absolutely correct, right? So this is what it means to have a point estimator. So if this is the only thing in your world you knew about Facebook, right? And I said, your life depends on it. Regina, guess what percentage of all adults use Facebook you would guess? Right, because you're not sure, right? It might be 0.4, but you would guess it would be 0.43 because you're going to just, so that's what it's saying, right? So our estimate of P, the population proportion is 0.43, right? And we can do this because this is an unbiased estimator. Half of the, right? Roughly speaking, right? Sometimes it will be more. Sometimes our P hat will be more. Sometimes it'll be less. But if you got somehow collected every possible P hat, they would all average out to the actual proportion. There are things that estimators that do not have this property, right? If this is the idea of a biased and unbiased estimator is confusing. If you forget, please review what you did, your homework from 6.3, right? Confidence interval. All right, remember, I kind of came up with one, right? Regina's confidence interval for my height was 5'9" to 6'1", right? So confidence interval is a range of values used to estimate the true value of a population parameter, right? Sometimes we abbreviate this to CI. If you're in law enforcement, that means confidential informant. This is nothing that cool. So if you are in a police report as CI number 3, don't make that your Twitter handle, because then people know that is actually something that someone actually did. Don't do that. That's stupid. I just had the computer generate these images. Some of them, that one kind of makes sense, but like, why is that a spider? I don't know. This is before AI was good. This is just the hit the design feature. I kind of like this is good for confidence level. If you're going to do some shit like this, right, you better be pretty confident of like your velocity when you hit the ground, right? I saw a video yesterday of all things where someone was parachuting and it tangled up as it came out. Luckily, you're supposed to have a reserve chute. She opened it like maybe 1 second before necessary. Yeah, why do people film this? So the confidence level, right? We actually call this 1 minus alpha. Don't worry too much about that, right? The percentage, right? So typically the confidence levels we use, and we'll mention this, is going to be 0.9, 0.95, 0.99. This represents the level of confidence, right? That we're sure that our value is in there, right? You can't really create a 100% confidence level, right? I mean, I guess theoretically you can. You could say, Bobby's going to be smart ass. He's going to say, I am 100% confident that the percentage of people who prefer vanilla ice cream to chocolate is between 0 and 100, right? That is always your 0.001 confidence interval for a proportion. But this isn't, you can't use this for anything, right? If y'all are going to be business folks, is anyone here planning to major in marketing? Minor, okay. Well, wouldn't you, if you're in the marketing department of ice cream, you'd probably already want to know what people's preferences are, right? Right? Maybe you want people to buy more of your chocolate, but if you're fighting uphill if you know that that's only the favorite flavor of 5% of people, right? So telling your boss, yeah, I'm 100% sure it's in there, yeah, that's going to get you canned, right? Right? Well, but if you can say, hey, that's all I'm 100% sure on, because that's just the way the world works, right? I'm 95% certain that it falls between 10% and 30%, right? And they would say, okay, maybe then you're 90% certain. So if I'm going to give a range for 90%, should the first number be more than 10? Less than 10? Well, I'm 90% certain, so I'm taking a bit more of a risk, so I can make my band a little bit narrower, right? I'm 95% sure it's between here, right? But maybe I'm 90% sure it's between 12% and, right? So as your confidence level goes down, your range is smaller, right? And therefore, the only one you can have is 0 to 100 for 100% confidence. Do we get that intuition, right? The more certain I want to be, right, of a fact, I have to give you a larger area that I can say I'm 90% certain it's here. I actually think it's in the middle of there, right? So if you said, give me your 50%, oh, that's. These are the most commonly used 3 ones. You could make your own one. You want to be 87% certain? Sure. They just use these keys. They're nice round numbers. If I'm doing this, right, for this class, we're going to just go that. But you could easily make a 99.9% confidence interval. I'm not comfortable. Is anyone comfortable 99% for this? I'm not. If I'm not sure that this is going to go. There's a one. Yeah, like all my. Yeah, you have 100 people jump out, and one of them it doesn't work. That's not an acceptable confidence level, right? Yeah, but we're not gonna use too many scenarios that are like that, right? If you're marketing ice cream, it's probably a little bit more chill, all right? Well, not even dying. It's just like, what's my marketing prediction, right? Yeah, and maybe in your guys' case. So here's an example, right? So there's many ways that people misunderstand confidence levels, right? And it's correct and this is hard to. I actually, when the first time I taught statistics, I had forgotten this. So I had a long conversation with my friend who's a PhD, well, he's studying for his PhD in statistics to really get the exact difference between these, right? I'm going to tell you that something's wrong, but if you use that wrong assumption, you'll be right most of the time, right? It's only like a technically wrong thing. So if you say my 95% confidence interval is 0.04 to 0.400, so 40.5% to 45.5%, right? You're saying we're 95% confident that this interval, right, somewhere in this interval is the true population proportion, right? Now you might be wondering, what exactly does 95% confidence mean, right? You're perhaps mentally translating you to say, I am 95% sure that P is in between these two values. Is anyone mentally translating it to that? Like 95, there's a 5% chance it's outside of those two values. It doesn't quite mean that. That's technically incorrect. Right, so it's technically incorrect to say that there's a 95% chance the true value of P will fall between those two. I mean, that might be more semantic. There is some true value of P, right? It's not it's unknown, right? But it's not being changed by this process, right? I'll show you what there is a 95% chance of a little bit, right? This is close though, right? It's close, and if you use this intuition, you will not be getting a lot of problems wrong, right? But I don't want to go out, even though that's not quite the correct intuition, I don't want to send you out there saying that, right? I could probably get away with this without doing this. This happens every day. This is
mock job interview, and you can use those resources.
This class is always interrupted by a tour. I love it. We should just start keeping the times when they walk by. You're like, you're 5 minutes behind schedule today. All right, so we could do that. All right, so this is not quite right either. What we're really talking about is the process. I haven't taught you the process, so it's still confusing, right? Somehow, somebody calculated this range, right? You imagine that there's some formula, right, or a procedure that you use to calculate this confidence interval, right? Does everyone imagine that that's how it works? Someone didn't just pull this out of thin air, right? So, and I will teach you that process, but first I want to show you what this means, right? So it is the success rate of a process. So I will teach you the process later, right? it involves using a formula, right? What it says is the process that is used to calculate this confidence interval will give you a confidence interval that covers the value 95% of the time. So let me explain what that means, right? So suppose the population proportion is 50%, right? But you don't know that, right? So just imagine this is only, right? This is Catholic school, so we can talk about it. Only God knows this. All right, so this is what God knows, right? Now, you do a process, right? It depends on your sample proportion, right? So Bobby goes out, he takes a simple random sample, he calculates this confidence interval, right? Notice this confidence, he says, I'm 95% certain that it's going to be in this interval, right? And in this particular case, okay, Bobby doesn't know this, but God knows the population proportion, everyone listening, right, is in that interval, right? But, right, Emma does the same thing. Bobby posts his procedure, right, for making this estimate online, right? Emma reads that paper and does the same thing, right? If it involves taking a sample of random people, it's not going to be the same, right? This is hers. She has a different confidence interval. I'm 95% certain it's in this range. See, we're 95% confident. Now, Bobby's was actually close, like his is more in the center, right? But hers still covers it, right? We could do this procedure many, many times. Sometimes it won't work, right? This sample, for whatever reason, it's an unusually low p-hat. And using the formula, they calculate a confidence interval, and they say, I'm 95% confident it's in this green interval. But only God knows, is it? Guys, is it? What's the actual value? It's 50, right? So it would be inaccurate to say that there's a 95% chance that P falls in here, right? There's a 0% chance because it's not there. What you're saying when you're saying I have a confidence interval of 95%, you're saying the procedure that I use to calculate the left and right range will work right? That procedure will work 95% of the time, right? So the procedure that I did, right, it will generate a left bound and a right bound, and that 95% of that time, that procedure will cover my interval, will cover my true value. Does everyone understand the distinction? Right, so you are doing a procedure, right, that 95% of the time will cover the true value. It's a little confusing, right? So maybe I want to give you guys a critical value, right? So we're trying to find like the 90%, right? Probability that that's where are going to fall in our values, right? Does everyone have one of these? How the hell are there only 5 people in the room right now? What the hell's going on? All right, well, yeah, so this is how you use that, right? And we're going to figure this out. So a critical value is the value that is kind of on the borderline, right? And, right, so for example, right, with a 95%, say, confidence interval, we would want 95% of our values to fall in here. So since this is symmetric, if 95% is in there is in the center, 5% is in the tails, right? So what percent is in each tail? Very, very easy. There's 5%, 95% in the center. It's very straightforward. So 95% is in the center. So 5% is not in the center, right? And it's symmetric. So what percentage is in each tail? I'm not sure what they're 2.5, just half of it, right? So let's like do this with, let's see if I have the t-table. Okay. So let's look at, so if two, all right, so remember those. So we want to find the hell. This z-score, right? This is going to be our critical value, right? So it's cutting off 5, right? And then this will be the same z-score over there. So looking at our table, right, it says that our table gives us the area to the left, right? So 95% is in the middle, but is that 95% what's to the left? Because Myra pointed out, what do we have in each tail? So let's look at our table. Can anyone find the value that corresponds to? So what percentage then is total to the left of this stick right here? Let's not look in there yet because we need to know what number to look for. 90.97, right? Because 95% is in the middle, right? So 2.5% to the right, 95% is to the left. So let's look at our table. So are we looking for a number that's on the edge of our table or in the interior, ladies and gentlemen? Yeah. So if we're looking for a number that's in the interior and finding the corresponding value that's on the edge, right? So we're looking for roughly 0.957. Actually, we were able to find it, well, it says exactly, but these are all rounded to the nearest thing. So what's the z-score for that? 6. You can see why we said this before. We actually were approximating something a little bit earlier. Remember we said that extremely, what was significantly low and significantly high? Was a z-value above 2, right? Because we said that 95% of the time you're within 2 standard deviations. It's not 2 standard deviations. 95% of the time, that was an approximation. You're actually within 1.96, right? So we used to, but that was an approximation. It would have been close for us to say 1.96, right? Is everyone following me why it's 1 point? Because that's what we just calculated. We found, right? We want a critical value that corresponds to 95%, right? So we want 95%. We're saying between Z being a particular value, (95% of the time) Z will be between 1 point and it's negative, right? That's what we just calculated on our table. I could do that for these other values, and I would get these. So I'm going to write these down, right? And you should write these down because these numbers you're going to use a lot. So either write them down on your table, write them down somewhere, right, that you will find them. Because this will save you from having to do repeated calculations. So I will also write them down. Is this a good marker? Yeah, that's a good one. So CI, confidence interval. Or actually, we want to say this is confidence level, CL. Right? The critical, and then CV stands for critical value, right? So confidence level, 90%. So those are our critical values, right? How do I find the margin of error, right? I use this formula, right? So I take this critical value. We can find the critical value, but the most common critical values we will use are those three up there, right? And this will be our formula for our margin of error. Notice this is the same thing as our standard deviation. This is the estimated standard deviation of a sample proportion. This comes from the formula for the standard deviation of a binomial distribution. Does anyone remember what Q means? How it's related to P? Yes. So this is P hat. That means the sample proportion, right? Because we don't have the actual proportion, right? So these are the things that means in there, right? You don't want to remember Q, you could just use this formula. Now, this formula doesn't work all the time, right? There's some assumptions this has to be, right? One, your sample has to be simple random, right? This is what is hard. All of our problems we're going to do is we're going to assume this, but this is actually hard, right? You wouldn't have to need a degree in statistics to be a pollster. If you could easily get a simple random sample, you could literally just do what we're going to learn in this lesson. And then you could be as good as pollster as anybody else, right? And then the binomial distribution. So you need to do a fixed number of trials. Each trial needs to be roughly independent, right? I say roughly is like if I choose a sample, right? If Bobby's the first person to sample, he can't be the second person. So that changes the population things. But since there's so many people, it doesn't really matter, right? And there needs to be 5, right, successes and at least 5 failures in the sample, right? So in the case of like ice cream, like if I said how many people, so a sample need to contain at least 5 people who favor vanilla over chocolate and 5 over chocolate or vanilla, right? That's the same thing as saying, right, number of successes, that's n times p. Number of failures is n times q. You don't need to check both of these because, right, if Q is bigger, just check whichever one of these you know is going to be smaller. For example, if P is 0.7, Q is going to be 0.3, right? So that means that this would be the smaller quantity. So if it's bigger than 5, that would be as well, right? Does everyone follow what I'm saying? Okay, so that's how we figure out E. Now we said our point estimator of P was, so how do you estimate P, the population proportion? You simply use the what? Yeah, what will be your best estimate? This is really straightforward. If I do a sample and 30% of them prefer vanilla over chocolate, would I guess that in the real world, 50% would prefer vanilla over chocolate, 10%? 30. So it's the point estimator is simply P hat. P hat is your best guess for P, right? So that means, right, your confidence interval, that's your best guess, right? But you're not sure it's correct. So here's your P, your number line, right? You're saying my guess for P is P hat, but I'm not so sure. But I'm fairly sure that it's within my margin of error of P hat. So this is plus E minus E, right? So if you say, I think 50% of people will vote for the Democratic candidate plus or minus 2%, I'm saying I think that the number of people voting for the Democratic candidate will be between 48 and 52. Fairly straightforward, right? And this is the same formula, right? Okay. So let's actually do this. So we have a Gallup poll of 14 to 87 adults, and 43% of them had Facebook pages, right? So when you want to get out of there is that N is 1487, and the population proportion is 43%, right? So first we need to find a margin of error. And anytime you're finding a margin of error, that corresponds to some confidence level, right? So we said the only thing we can be sure is somewhere between 0 and 100% of people have a Facebook page, right? What we need to do is find a margin of error that corresponds, right? We want to find a place, right? Notice we're doing a procedure, right? This procedure, we're basing off of a p hat of 0.43, right? But someone else could choose some other different sample, right? If they followed the same way of collecting this sample, right? Sometimes they get 0.43, sometimes they might get 0.48. We want to have it such that the procedure, right, that using our particular error width band, that 95% of the time it will contain the actual value, all right? So we want to find first the margin of error, then the confidence interval, and then we want to say, can we safely conclude that fewer than 50% of people have Facebook pages? We want to write it in a way that could be understood by a normal person, all right? Ordinary person. There might not be normal. Okay, so first we have to make sure that we can use the formulas. What are the requirement checks? We just mentioned them. The requirement checks are, but what do we need to be able to use this formula? We need to know these following things. Yeah, we need to know, this is it, Bobby, it's these, right? So the sample is simple random. This is Gallup. It's one of the most reputable. It won't actually be simple random, but we can treat it as if, because it's a good polling company, right? They wouldn't do that. Fixed. Is there a fixed number of trials, and are there 2 outcomes for each trial? Yeah, right. You choose an individual and they either have a Facebook page or they don't, right? And it's independent. We following, guys? Finally, right, we need to show that NP and NQ are both more than 5. This is the sample size. 43% of them have a Facebook page, meaning 57% don't. Are there at least 5 people in each group here? Are there? This is really 43% of this plus 1,000 sample have a Facebook page. Is that more than 5 people? Is it a lot more than 5? And what about, do a lot more than 5 people not have a Facebook page? Yes, so by far, right? So the minimum stage is set. So now let's solve the problem. Find the margin of error that corresponds to a 95% confidence interval. So I just mentioned it, and you hopefully just wrote it down. What is the formula for E, the margin of error? Huh? No, it's a formula. It's a formula that's based on piece of information. We just mentioned it. Yeah, so it's critical value. That's Z alpha over 2, square root of, and hat specifically, right? Because we don't know the exact proportion, right? Okay, so let's calculate that here. So the critical value is the value that is one that corresponds to the confidence interval, right? And we prefigured this out. What is the critical value that corresponds to a confidence level of 95%? Everybody, you just have to look in front of you. 1.96. All right, 1.96 times p hat, which is and q hat is going to be just 1 minus whatever that is. Yeah. Mm-hmm. Nope. 1 minus 0.43. No. This is the portion that does not, right? You always multiply 2 numbers that add up to 1, all right? And you divide by n the sample size. What's the sample size in this case? It's literally written up there. Yeah. You plug that into your calculator, you will get roughly 0.025, which is roughly 2.5%. So that's our margin of error. So that means the process, right, 95% of the time, you collect a sample of this size, a simple random sample of this size, 95% of the time, it will create a value. Your p hat will be within 2.5% of the actual value of p, right? So to create the confidence interval, all we need to do is right? P hat is our point estimator, so that's what we're going to center ours around, right? So we're going to say 95% of the time, subtract the error from P hat. Right? You end up with, this is why I use this is what we got before, right? All right. What do we think? Can we safely conclude that less than 50% of adults, at least when this sample is taken, it's probably changed now, have a fit, less than 50% of adults have a Facebook page? Less than 50%. What do we think? Got all day. The answer is right in front of you, trust me. So what did we conclude for B? Yes. We're 95% confident that the proportion that has Facebook is between and a half, right? 40.5 to 45.5. So can we safely conclude that the proportion of people who have a Facebook page is less than 50%? Yes, absolutely, because we are 95% confident he is between all right. So yeah, if we're 95% confident it's in between these two values and 50% is not in that range, then we are more than confident that, right, the probability that's less than 50% would be even more than 95, right? Does everyone follow why this is the case? Right? Our value that this 50% is outside of our confidence interval. So there you go, right? So we are definitely more, so we are fairly safe that it's not more than 50%. Now, can we be certain? No. But we can look at that it's particularly unlikely. All right, so I want you guys to do this next one on your own, and I will check in with you guys, right? But this shouldn't take more than 5 minutes. I'll give you the formula. So here, let's just break a little bit of it down, right? So I want you to do A, and I'm going to give you B, right? Find the CI. which is the confidence interval, okay? So let's start with A. Let's try to take out some certain piece of information, right? We're trying to find a confidence, right? First, the margin of error, right? What does this 1250 represent? That is N. This right here represents what? The 27%. That's equal to what variable? Is p hat, right? The population proportion. We want to write it as a decimal. Right? You can easily see 27%, right, of, are there at least 5 yeses and 5 nos in our sample? Like, right, 27% of this, right, there'll be at least 5 people in each group, so we can use it. Our confidence level here, everybody, is you just read it. Okay. So what's the formula that we use to find the margin of error? It's E is equal to, we just used it 5 seconds ago. Yeah, Z alpha over 2. What's the rest of the formula, Bobby? You have it. Square root. All right, so you have all the information, right? So that'll give you a margin of error, right? And you can use that to find the confidence interval, because in the center of the confidence interval is always, what is in the center of the confidence interval? P hat, right? You go to the left E and the right E, right? So just follow this calculation here. You should be able to do this fairly easily at this point, right? We've given you the recipe. All you have to do is perform. Okay, so let's plug this in. So Z alpha over 2 in this case is equal to, right. Notice we're looking for a confidence interval that puts 90% in the center, right? So that means you would be looking in the body of your table for the Z value that gives you 95 in the body of your table, right? So if you didn't have this table, you could, because I could just make up, right? Like these are nice because we use those 3 the most often, right? But I could make up any confidence level, right? I'm going to be looking for 0.95. And notice that's between 1.64 and 1.65, which is exactly why it's 1.645. So that's actually really the hardest part now. What's the other values? P hat, everybody, is? Yep, sorry, you're not looking at this. 0.27, which means that Q hat is, Bobby, so you got it right? Mm-hmm. And N is? All right. When you do this, you get roughly 0.021. Anyone else get that? So that is your margin of error, right? So that's our margin of error. So you do plus or minus around your best guess, which would be the p hat, right? Because, right, if you have to guess a single number, right, you might as well go with, right, what percentage of Illinoisans own more than 2 vehicles? Well, of my sample, it's 27%. That's all the information I got. So for B, all I do is 27% minus 2.1%. So everyone get this, right? Notice this is a fairly small range, right? Ish, right? Now our sample size is what? Is that a large portion of people in Illinois who own of Illinoisans? No. So analyzing polls, right? The quality of a poll depends on the sampling method and the size of the sample. But guys, and this is something that I saw, right? Everyone, I want you to listen and burn this in your mind. The proportion that the sample is of the population is not important, right? So this 1,000, whatever it was, 250 people, that is a tiny proportion of people in Illinois. But that sample size itself was big enough for us to make this conclusion, right? As long as those people are selected randomly, that's okay, right? So never say something is not reliable because a small portion of the population is sampled. The more people in the sample, the better it is, but it doesn't matter how big the population is. Different rare cases, and those rare cases will never come up in this class, all right? Other thing is confidence level should be provided, sample size should be provided, right? So the confidence level here was, but when they say, a lot of times it's not. The media says it's plus or minus 2%, right? But obviously they're not 100% sure it's plus or minus 2% of that value. It's some other confidence level, and a lot of time that's missing. But typically it's 95 is the most common one. So if you're not given one, you can guess that it's 95. I'm saying this again because this is not intuitive, right? This seems wrong, right? If I collect a simple random sample, right, and of 200 people, that is as good for a population of 2,000 as it is for a population of 2 million. Okay? As long as it's simple random. The only thing that matters is the sample size, not how big the sample is compared to the population, okay? At least some of you here have mentioned that as a reason why something was not reliable, right? Does anyone remember writing something like that on the first celebration? Yeah, but that's not relevant. Right. Now, if they give you the confidence interval, the margin of error, the point estimate, right, should be, sometimes they might just say the confidence interval, right? If they say, hey, the confidence interval is from 70 to 80%, right, or 0.7 to 0.8, Well, since the confidence interval is symmetric, right, you would then know that p hat is in the middle, so it'd be 0.75, right? And since you go from the middle, this is E, margin of error in one way, margin of error in the other way, right? Those differ by 10%, which means the margin of error is 0.05 or 5%. You probably would have guessed this anyway, right? Does that make sense? If I give you a confidence interval, your point estimator, right? Usually I give the point estimator first, right? Is going to be dead in the middle of that confidence interval. And then the margin of error would be the difference between that point estimator and either of the ends, which would be half the distance between the two ends. Determining sample size, right? So before, remember, n was part of our calculation for figuring out sample size, right? Now we're going to do the opposite. So here, we said, we calculated, right, our margin of error in that last sample, which was, I think, 2.1%, right? Let's say, I don't know why, but Bobby here, he's fascinated by what percentage of Illinoisans actually own 2 cars, right, or more. And he wants to be within 1%. We're going to need to have a bigger sample, right? So here's the formula for calculating sample size. Notice I'm going to go really fast past this because you already know this, right? Now, a lot of time, so there's 2 different formulas here you use, right? Let's say I'm doing a sample and I want to know what proportion of Americans have been to Yellowstone Park. I have no idea off the top of my head. None of you do either, right? So the problem is this formula for n needs you to have at least a guess of what the population proportion is, which not all the time, most of the time you might not have, because the whole point of the study is to figure out what p is, right? Until you do the sample, you don't have a p hat, right? But maybe there is a previous study done and it was 10% in that study, but I don't completely trust it. So then I can use my estimator, right? Then I can estimate. If you don't have any idea, right? I have no idea what percentage of people have been to Yellowstone, right? Instead of using p hat times q hat, you use 0.25. The reason why you do this is, and you can easily show this with some simple algebra, I don't have time, right? This is basically your worst case scenario. Q hat times p hat, these don't pack up, will always be less than 0.25. So if you use so that's the largest that factor can be. So the most conservative estimate would be make n as big as you need. Now, how do you round? Well, one, if this is a formula, right? Most of the time, an integer is not going to pop out of it, right? Now, if you get a number like this as your n, you might think round up, round down, right? Because it's closer to down, right? But you always round up for these calculations. Any thought about why? Would you rather have your sample be bigger than it needs to be or smaller than it needs to be? Exactly, right? This is the minimum size that's safe for the confidence level that you want, right? So you have to round up, right? If I require at least, right, this is a lower bound, right? N has to be greater than or less than this to be sufficiently large, right? So you go up. Just like if you calculate, right, hey, to carry 80 people, right, if I have 80 people and a bus holds 60 people, I need 2 buses, not one, even though when I divide, right, 80 by 60, I would round down. Everyone following? So at the time, there was no percentage of people who buy stuff from online stores, right? Okay, so just guys, please don't pack up because I'm going to write this out. This is me actually doing this, right? I'm going to take about 5 minutes to do this or less. Hopefully that will be all right. So he wants to get an estimate of, and this is an old book, so definitely more than 80% of adults use online shopping. I think everyone who has not used online shopping thinks like I have an aunt who thinks that, I don't know, anytime you put your credit card number in, like, I don't know, like Russian hackers will control your life or something. I don't know. But almost everybody. So, right. Yes, I actually know. Well, so let's, I don't have a, hang on a second. Give me a second. I just need a white space to do this. We'll just use the formula, all right? Okay, so I just gave it to you. So A, what's the formula you use when you have an estimate of where you have a rough idea of what you think the proportion is? It's N equals, we just gave it to you. That's a number. This is the problem. Here's the formula. All right, we want N. So we just have to gather that piece of information. So the critical value always depends on the confidence. What's CL stand for? Yes, your confidence level always has a corresponding critical value, right? So our confidence level in this case is the most common one, right? You can easily memorize this. Now, so we don't know the proportion, right? That's why we're doing this study, but the best guess from a previous piece of literature was 80%, right? So 80% was our best guess for p hat, right? If 0.8 is p hat, everybody point Q would be 0.2. And then it's over E squared. E is the margin of error. What do they want the margin of error to be here? Say that again. So let's use E to be 3%. But I want to write that as a decimal. So that would be 0.03. You type this in your calculator. You will get roughly 682.95. So the minimum required sample size would be so that's the number my calculator gave me. Is it possible to have a sample size of that with a decimal? Is a decimal possible for a sample size? Can that many people be included in a sample? How? How can I include a 95th of a person? And I'm going to round this up, right? Okay. So that's if you have an estimate. If you don't have an estimate, what do you use instead of p hat, q hat? 0.25. So you do everything else the same. Forgot to say that that's squared. I pre-did the calculation, so don't worry about that. You do this, you're going to get a larger number. See, if you don't have an estimate of the population proportion, right? Since there's more uncertain, you need to have a larger sample size to be safe. Now, do I round this down to 1,067? No, what do I always do in this case? Round up, because this is the minimum required sample size, right? If I round it down, I would just be below the minimum. So then this sample size would be 1068 people. Okay, you now know everything you need to do for